In this video, we're going to focus on simplifying expressions by using exponent properties, and we're going to specifically focus on negative exponents. So as we begin to explore this fifth property, we're going to try to figure out what those negative exponents really mean. So what we're going to do is we're going to plug the following into our calculator and actually figure out what these six statements mean and how the positive exponents and the negative exponents actually relate together. So if we start with this first problem here, we look at 2 to the power of 2. So if you take parenthesis 2 close parenthesis to the power of 2, press enter, you should get 4. And now what I'd like you to do is I'd like you to push 2 to the power of, you're going to do caret negative 2, and press enter. And what you should see is that you get a value of 0.25. So notice that this didn't make the answer negative. It made the answer a decimal. And if we think about 0.25 for a second, I know that 0.25 represented as a fraction is 1 over 4. And if I look carefully here, I see that 2 to the power of positive 2 is 1 over 4. 2 to the power of negative 2 is 1 over 4. So they're very, very similar. They both involve 4, but 2 to the power of 2 is 4, and 2 to the power of negative 2 is 1 over 4. And then if I take this one step further, I know that 4 can really be represented as 2 to the power of 2. So hopefully what you're noticing here is that these are just flipped fraction versions of themselves. They are reciprocals. And let's see if that same pattern continues as we look at the next couple examples. So here we have 2 to the power of 3, and I know that that is 8. And then if I take 2 to the power of negative 3, I get 0.125. And if we look back up at that first example, what we saw happen is we saw that we had 4, and it became 1 over 4. So what I'd like you to do in your calculator is test it out. If we apply this same pattern down here, that would mean that 0.125 as a decimal, if we turn that into a fraction, it should be 1 over 8. Again, the reciprocal, which can then be written as 1 over 2 to the power of 3. And if we test that out in our calculator, we see that it is, in fact, true. And then if I look at this last example here, 2 to the power of 4 is 16. 2 to the power of negative 4, if I plug that into my calculator, is 0.0625. And again, if I'm using this concept of picking up on patterns, what I expect is that 0.0625 written as a fraction would be 1 over 16. And if I test that out, what I find is that it is. 1 divided by 16 is 0.0625. So what's happening here is negative exponents don't turn your answer negative. Negative exponents can simply be rewritten as positive exponents if we write them as their reciprocal, or we move them to the other side of the fraction. So what we're going to do here is we're going to use this property, and anytime we have a negative exponent, we're going to rewrite it as an expression with positive exponents by using this concept of the reciprocal. So what we learned on the previous slide is that when we have a negative exponent, we can essentially change the exponent to positive, or we can rewrite the expression by using the reciprocal, and then we're able to rewrite that expression so it doesn't have negative exponents. So for example, here you see you have 2 to the power of negative 4, and I see that that has a negative exponent. But what we learned on the previous slide is if we turn it into its reciprocal, that exponent becomes positive. So remember, the reciprocal is flipping the side of the fraction that a value is on. So here I'm going to take 2 to the power of negative 4, and I'm going to put it over 1. And in order to turn this into the reciprocal, I need to move that item with the negative exponent to the opposite side of the fraction, which in this case is our denominator. So what we're going to do here is we're going to rewrite this with the 2 to the power of negative 4 moving down into our denominator, and as it moves to the other side of the fraction, it actually becomes a positive exponent. So notice that as it moves to the opposite side of the fraction, that exponent becomes positive. Now, we can't just leave the numerator of a fraction blank. So remember that if there's nothing left in the numerator, there's really a 1 there. So here we were able to rewrite that expression with positive exponents. Now if we look down at the second example, what we notice is we have a negative exponent down here in the denominator. And this same concept applies. We can rewrite this with positive exponents if we use the reciprocal. So we need to change which side of the fraction this is on, which means it needs to move from the denominator into the numerator. So here it moves into the numerator, and we have 2 to the power of 4 now in our numerator. And as it moves up, as it changes side of the fraction, that exponent changes signs and it becomes a positive value. And then here you can put a 1 in your denominator, or you don't need to write it at all, and you can just write 2 to the power of 4. So here we're going to rewrite all of the following with positive exponents. So here in example A, I notice that in my numerator, so if I turn this into a fraction, I notice that in my numerator I have something that has a negative exponent. So what I'm going to do is I'm going to take that value with the negative exponent, and I'm going to move the entire term to the opposite side of the fraction, which in this case is the denominator. So I move it down into my denominator, and I have a now to the power of positive 7. And then I can't just leave my numerator blank, so I put my 1 in there to complete my fraction. Now from here, if we look at example B, we're actually going to have to use our powers to powers property here in order to help us get rid of those parentheses. Now, I know that anything without an exponent really has an exponent of 1. And then if I look on the outside of those parentheses, the second power on the outside, the powers to powers, is a negative 2. So I'm going to start by multiplying each exponent inside of those parentheses by a negative 2. So here I have x to the power of negative 2 and 5 to the power of negative 2. So now from here I'm noticing that I have 2 items with an exponent that is negative. And what I can do is I can move them both to the opposite sides of the fraction so that those exponents become positive. So I'm going to move this term with the negative exponent of negative 2. So I'm going to move that x term down. And as I do so, as I move it down there, that then becomes x to the power of a positive 2. And then I'm going to move that 5 to the power of negative 2 into the numerator, the opposite side of the fraction. And what's going to happen there is that exponent becomes positive, and I have 5 to the power of 2. Then from here, this is actually a pretty simple one to simplify. 5 to the power of 2 is just 25, and then x squared stays positive in the denominator. Now if we look at example C, here I notice that I have one term with a negative exponent, so I'm going to move that to the opposite side of the fraction, which in this case becomes 3 to the power of positive 3 in my numerator. Then I can put a 1 in my denominator, or I can just write 3 to the power of positive 3, and that is 27. And then finally, if I look at example D, what I notice is I have one term that has a positive exponent and one term that has a negative exponent. So I only am going to move the terms that have a negative exponent. So here, because B has a negative exponent, I'm going to move it to the other side of the fraction, which is the denominator. But because this is positive, I'm going to leave it exactly where it is because I don't want it to become a negative exponent, and if I were to move it up, it would become a negative exponent. So here I'm going to have a to the power of 4, b to the power of now a positive 6, and then because there's nothing left in my numerator, I just have a numerator of 1. So notice how we only moved one term. We moved the term that had the negative exponent and left all positive exponent terms alone.